I welcome you all to this tutorial on writing your chapter 3 methodology. Writing chapter 3 of your undergraduate final year project report. I'm your host, Engineer Adebisi AT Kim. And you can reach me via Engineer Adebisi at gmail.com. Now let's begin how to write chapter 3. Before we begin with the mechanics, exact method of writing chapter 3, it's important to know there are two chapter 3s that we use in most colleges and institutions. There's the pre-data and the post-data. In some institutions, students are required to write the first draft of their methodology, which is usually a pre-data, what they intend to do before they carry it out. This will help their supervisors and assessors determine if the students will complete the project in time. It will also help the supervisors and assessors to know if the student is prepared, willing, and ready to undergo the project. This will also help the supervisors and assessors to determine if this project needs assistance from someone else or another input that can delay it. In most cases, you need to write the pre-data report. What is now the difference between the pre-data report and the post-data report? The pre-data is written in will be future tense. For example, if we were working with the Gary sieving machine, our pre-data will sound something like the materials will be procured from Ikirun and Osogbo. In our post-data defense, it will be the materials were procured from Osogbo and Ikirun. These are some of the language patterns that are different. Also, in our pre-data report, we want to know what are the machines that will be used, where will it be used, and like that. For our post-data or the final report, we want to know the machines that were used. You might intend that, okay, we'll be using bench sharing machine for the sheet metal and chisel, and at the end of the day, you don't even use sheet metal, you end up using another material. The final report will capture that, while the pre-data will be this and this are what we will use. That aside, what are the content that go into the chapter 3 methodology? So first, let's take a sneak peek into the conference paper. And you see first here, you see the design calculations. You see the design calculations. Very important. You see the drawing, very important. The fabrication procedure, that's for the final report. Fabrication procedure, the drawing, also the cost, bill of quantities, or bill of engineering measurement and valuation, anyhow you choose to call it. So let's begin with one. Let me start with this. We're using construction of a Gary sieving machine. 3.0 would be something like design consideration. Before we start this Gary sieving machine, what are some of the factors you want to consider for your design of this machine? Of course, you'll be using the cost. The following were used as factors to determine the materials and method used for the design and construction of the Gary sieving machine. You highlight them. Also, You also be having 3.1, say the materials to be used. 3.1 can be, say, the visual design, engineering design of the machine. So, as you already know, in engineering, before we design something, before we manufacture something, we need to design it. So maybe you've used AutoCAD to draw it, or you used SolidWorks to draw your machine. You need to put the assembly drawing alone here. Other drawings on the working drawing can go to the appendix, but the assembly drawing will be here in the engineering design of the machine. You also need to specify which software did you use to make the design of the machine. After that, you need the 3.2 design calculation. Design calculation is okay. Your machine will have a size of 150 millimeter, 150 will have a size of 1.5 meters long and 2 meters high. How have you come to this calculation? How have you come to that height? Did you just take a measurement? If you did take a measurement, what were the factors you took before you take those measurements? Those will be under your design calculation. Also, for your design calculation, you will need to consult engineering design textbooks. For example, how do you design a hooper? How do you know that this machine, 1 horsepower will drive it? How do you know that you'll be using V-belt as against flat belt? If you go into an elementary machine design and machine design textbooks, there are different chapters for each of these. Let's take a cue from this project. So you see something like design of the truss bearing. P, the pressure per unit area equals to W, which is the load transmitted over area. This is a formula gotten from a engineering design textbook. So you do that as well. After that, no, that's not what we want. After that, your design calculation, you also need to give us your 3.3, the method used. When designing your machine, when constructing it, what method did you use? Did you use casting? Did you use cutting and fabrication, welding? Did you use riveting? What exact method do you use? And also you need to take us through the method step by step, starting from the procurement of the material to the finished product. If it was welded or casted, you need to give us pictures of instances in the manufacturing process. If you're writing a predator report, you don't need pictures of instances because you've not done it. You say the machine will be manufactured, will be produced using this method. Then you give examples of those methods and the advantage of using that method and why you've chosen that method. Also in your chapter 3 will be your bill of quantity. This your bill of quantity. In some places they call it bill of engineering measurement and evaluation. So this is a place a lot of students are stuck. So I'll quickly do a brief demonstration of it. For your bill of quantity, first you want to draw it as a table. So I go to insert and I insert a table. What are now those things that make up your table? First, the serial number, the item or the particular, the rate, which is the unit cost, the final cost, and the quantity, making 5. So I need 5. 1, 2, 3, 4, 5. Let's draw the table this way. The first one will be serial number. Next will be the item. You can write it as particulars too. Then the QT1, the quantity, the rate, and the amount. So number 1. Say for this project you used an angle iron. You need a brief description of it. Is it 50 mm angle iron? Is it 25 mm angle iron? So you need to be a little bit descriptive. Quantity. How many lengths of the angle iron did you use? 10. How much was one? One was 5,000. If one was 5,000, pardon me, if one was 5,000, then the total will be 5,000 times 10, 50,000. So you go this way until you are done. On the last one, you need to write your total, which is a gross total of this. And also before the total, you need your miscellaneous. Miscellaneous is usually 10% of the cost. This your miscellaneous is a standard item on the bill of quantity because there will be some cost that you won't have factored in, which your miscellaneous will bail you out. Also, in writing your bill of quantities, in some schools, it is not accepted to have a table this way. They want just 3 lines for your tables. So you want to format it. First, you want to go to the borders, want to go to no borders. Then they want the first line to have horizontal line, bottom, and also top. And they want the last line to also have a bottom border. However, this is not for all schools. Anyhow they write in your school, do consult with your school so that you know the right formatting that is to be used. What is left to be covered? Check. Methodology. What methodology is? We've covered that. Pre-data, post-data, we've covered that. Machines, the items, we've covered that. Design, we've covered that. Bill of quantity, we've covered that. With this, you will have written a good chapter 3 that your supervisor will be proud of. Again, while writing your project report, there are so many things you write and you feel they are the best in the world. But your supervisor, because of his experience, will say, no, go and change this, change that. Important, you are teachable and you are open to correction. If you'd like to contact me, I am Engineer Adebisi and you can email me right there. I do wish you the very success in your engineering pursuit. See you next lesson.